Hey everyone, today we are going to be talking about finding the mean and the standard deviation of a discrete random variable by hand. So we did talk a little bit about how to do this on the calculator the other day, but now we're really going to get into doing it by hand and showing our work, and then it's going to come together with the calculator again. So we did the other day talk about the measures of center, and we revisited that. We have the mean and the median, and we talked about how to find the median from the probability distribution table. So now we're going to talk about how to find the mean by hand and the standard deviation by hand. So the mean, another name for the mean, is the expected value of a discrete random variable. So it says the expected value is the average over many, many repetitions of the same chance process. So if we had done something in the long run many, many, many times, this would be the number of whatever the X is that we're counting that we would expect to obtain. So there is a formula on this sheet, and it is also on the reference sheet, and I want to show you that here. If you look on my formula sheet where it says probability, which is Roman numeral 2, underneath it says discrete random variable X, and it says mean. So I'm going to circle that, and right now we're looking here. Notice we have the symbol mu for mean, and that means population mean. And we also have E of X. E of X means expected value of X. And then we have this symbol here. And this symbol is called sigma or summation. And it's telling us to multiply every X times its respective probabilities. And that sigma means add them all up. Okay. So going back to my notes here, this is the formula. Again, it's from the reference sheet. So you don't have to worry about memorizing it, which is nice. The mu again means population mean. The E of X means expected value, which is now known as a synonym for mean. And here it's telling me that we're going to take every X and we're going to multiply by its respective probability. So this first X times its probability, second X times its probability, third X times its probability, and then this sigma means add. So we're going to add them all the terms up. So what it is it's kind of like a weighted average. So I want you to think about when you're finding the average of something, usually you add everything up and then you divide by the total number. And that would be if all the things, whatever it is that you're doing, let's say students in a class and their test scores, if they all weighed the same amount, we would just divide up by the total. But in this case, the probabilities are weighted differently depending on what it is. So oftentimes, thinking about grades, for example, you guys will have your test grades, you'll have your quiz grades, and you'll have your homework grades. Your test grades will be weighted out of 60%, your quiz grade will be out of 30%, and your homework will be out of 10%, for example. So we'll take our test average, whatever it is, we'll call it T for test average, and we'll multiply it by its weight, 0.6. Our quiz average, we'll call it Q, will be multiplied by 0.3, whatever its weight is. And the homework average, which I'll call H, will be multiplied by 0.10. And then what will we do with those numbers? We're going to add them all up. That's kind of the concept here. X times P of X, X times P of X, X times P of X, and then add them all up, okay? So let's actually look at an example now. So we've seen this example before. We talked about it with the median, and now we're going to talk about it with the mean. So Pete is charging $150 per person for his Jeep tours. The C, capital C, is going to be the total amount of money that he collects. That's going to be the random variable that we're interested in. And the P of X, or P of C, in this case, is going to be its respective probabilities. So as you can see, there's a different probability for getting $300 versus $450, et cetera, et cetera. They're all weighted differently. So if we want to find the mean for his distribution, which we'll call mu of C or E of C, I'm going to put E of C, we're going to do the formula that I just specified. We're going to multiply 300 times its probability, 0.15, 450 times its probability, et cetera, and then we're going to add them all up. Now, on the AP, it's understood that you don't necessarily have to write all the terms out. I'm going to write them out for right now, but I do want to mention you can actually do the first term times its probability, and you can do a plus sign, a dot, 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 and then you can do a plus sign, implying that you know that addition is happening in between the terms. And then you can just do the last term, which is going to be 900 times 0.05. So that is actually acceptable to show work. And basically what you're going to do is you're going to write the formula in symbols. So you're going to write sigma, which means summation, which means add them all up. Every x, which in this case it's c, times its respective probability. And then you would show this line of terms here, and then you would just write what it equals, okay? So, I mean, yes, I could sit there and I can write 300 times 0.15 plus 450 times 0.25 plus 600, etc. But it does get tedious, as you guys can see, and I'm even running out of space. But it is really great if you can just write the first term, the last term, and a dot, 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 and then you can write what it equals, all right? So now you're going to take out your calculator and you're going to actually do this. You can do this in the home screen of your calculator, showing that you're multiplying all the terms and adding them all up. Okay, so I entered all of that in my calculator, and you guys can see I got $562.50. So that is going to be the mean or the expected value for Pete. All right. So how do I interpret this in context, you ask? Well, if you look back at the previous slide, it says that this is the average value over many, 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 many repetitions of the same chance process. So if we think about Pete and his Jeep tours, if Pete conducted many, many, many Jeep tours, he can expect that his C, which is the total amount of money that he collects on a randomly selected trip, he can expect that he will get an average of $562.50 collected, okay? So we're gonna write that down right now. If Pete, let's see if I can get my typing here. If Pete gave many, many Jeep tours, he would expect to collect an average of $562.50 per trip. Okay, so that is the concept of the expected value. It's kind of like in the long run, what we expect will happen if we do this many, many, many times. Remember, averages are not resistant to outliers. So you might have a really good trip and then you might make a lot of money, or a really bad trip. So now, as you guys can see here, you have a histogram. It's a probability distribution histogram. And look, there is a triangle here, and the triangle is representing the mean. And notice they have the amount, which is 562.50, denoted right here. And remember, the mean is kind of like the balance point. If you had made this into a block of wood, the mean would be $562.50. If we move that lever, the mean would be located where that wood would balance appropriately. Now, there is another way to do this on the calculator, and we did go over this the other day. So I'm just going to mention the steps again for you. On the calculator, to check your work, we want you to check it. If it's a multiple choice, you can totally do it on the calculator. But if it's a free response, they want you to show the work by hand, like I just showed you. But again, you have to write down the formula first, which is this one. Then you're going to write out the terms, the first term, plus sign, dot, 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 plus sign, last term. And then you can write the answer from the calc, and you can check it in the calculator. But they want you to at least show that you understand the formula and what's actually happening behind the scenes. Now, if it's multiple choice, you can just go right to the calculator. So what you're going to do is you're going to press stat, and then you're going to go over to where it says calc, and you're going to go to one variable statistics, and you're going to make sure that your data is in L1 and L2. L1 is going to be your X list, which in this case would be your costs, and L2 is going to be your frequency list, which is going to be your probability. So after you write that down, I'm going to show you how to actually do it. Okay, so I'm going to do it myself by entering the data in L1 and L2. Okay, so as you can see in L1 here, I have my X values, which are the cost that he could possibly get when he's collecting his money, 300, 450, etc. And in L2, I have the respective probabilities. So now what I'm going to do is I'm going to go to stat, I'm going to go over to calc, I'm going to choose number one, and make sure where it says one variable stat, make sure you're not using two variable stat. It's still one variable we're measuring. It's just the probabilities are the frequencies associated with those respective probabilities. So be careful. The list is L1 and then the frequency list is L2. So second, two, and then you just hit calculate and then you should get the same mean. So if you look on the top here, it's not called mu on the calculator, it's called X bar. But notice it's the same mean, $562.50. And that is what we just got when we did this by hand, remember? So I'm just going to show you those steps again. To note, you first really should go to these red steps here. First, you're going to go to stat edit, enter the data in L1 and L2. L1 is the X values, L2 is the probabilities. After you do that, then you're going to go to stat, calc, one bar stat, L1, L2, and then you're going to get the mean. So I put first here, you're going to do this, and then we're going to do that. And the mean on the calculator says X bar, but it's really mu in this case because it's a population of all of Pete's costs that he collected, all the money he collected over time from his distribution. Now, if you scroll down, I would like you guys to do this example. I just want to mention again that you don't have to write out all the terms because there's so many, right? There's 11 terms. So what you're going to do is you're just going to write your formula, mu of x equals E of x. You can copy it down right off the reference table. Sigma xi times p I. So this just means multiply, 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 add. Okay? So you're just going to do the first term, which is 0, times its respective probability, plus the next term. And again, you don't have to even write the next term. You can just write a plus sign, dot, 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 implying you know addition is happening, and then go to the last term, which is 10 times 0.053. Okay, so put this in the calculator. You can either use your L1, L2 right now to do it and find the mean, or you can actually multiply 11 terms and add them up and see what you get. And then I want you to interpret it in context. Okay, I'm going to let you guys do this one. Now moving on, we have an AP question. So read it over and check it out. Okay, it says a nonprofit organization plans to hold a raffle. A total of 1,000 tickets are going to be sold for $1 each. After all the tickets are sold, one ticket will be selected at random and its owner will receive $50. The expected value, let's circle that. That's important because that's the mean for the net gain for each ticket is negative 0.95. What does this mean in context? All right, so I want you to read the choices and tell me what you think. Okay, so I want you to think about this. Not every person is going to win the raffle. Some people are going to win, and one person is going to win, and everyone else is going to lose. So if they're paying $1 each, think about most people are going to be losing money. And if you lose money, when you talk about your net gain, if you're losing money, you're actually not gaining. You're losing money, right? So you have a negative gain, okay? So it's going to be a negative number. If you're the only winner, it says you're going to receive $50, right? But you're really not receiving $50 because your net, if you think about it, is going to be, you would have to take away the $1 that you laid out for the ticket. So if you are the winner, you are going to have a positive net. And if you are the loser, you're going to have a negative net. So I know they didn't even ask you for this, but I just want to mention that if you are the winner, you have a 1 in 1,000 chance of winning. And your net gain is going to be 50 minus 1 because you had to lay out $1. So your net gain is going to be $49, okay? Now, if you are the other 999 people, you're going to lose because only one ticket was picked. So that's going to be 999 out of 1,000 is going to be the probability of losing. And those people, they just gave $1 away and they didn't win anything. So their net gain is actually a loss. It is a negative $1. Okay. So I want you to think about now that expected value formula. The expected value formula is take every x and multiply it by its respective probability. So remember, we would multiply along the branches of the tree, multiply along the branches of the tree, and add it up. So the probability of winning, there's only one winner, is 1 out of 1,000. And actually, I'm going to switch it to the x first and then the p of x second so you guys can see the pattern here with the formula. So the x that you can win is $49, and its probability is 1 out of 1,000. And then the probability of losing is 999 out of 1,000, and the net gain is negative $1. So you're losing one. The probability of that is 999 out of 1,000. So what we're going to do is we're going to multiply, multiply, and add. These are the losers. There are 999 of them, and there's one winner, and then you would add it up. And guess what you're going to get? You're going to get the negative 0.95 as your mean or expected value. So what does that mean? That means that on average, people are losing money. How much? They're losing an average of 95 cents per raffle ticket. So if you picked choice B, you were right. But what you really need to know is that not every person is going to be losing 95 cents exactly. Most people are going to be losing an actual $1, but the winner is going to be winning $49. So if you average all that out, that's where you get the negative 0.95. Okay, so that's the concept of expected value, is it's an average gain or loss. Now, not only can we find this mean, which is a measure of center, but we can also find a measure of spread using formulas, and that is called the standard deviation, and we can also find the variance. They are related to each other. So the variance is actually the standard deviation squared. The standard deviation symbol, which you've seen before, I'm sure, is the symbol sigma, lowercase sigma. So I do want to mention that we just saw uppercase sigma, and now we're talking about lowercase sigma. They're two different things. This is little sigma or lowercase sigma, and this is capital sigma, which means summation. So two different things. So if we are talking about variance, it is lowercase sigma squared because it's the standard deviation squared. It is also denoted sometimes with the word VAR and then an X for the random variable. Now, what is the formula for the standard deviation? Well, the formula is actually also on your reference sheet. So if you look next to where it says discrete random variable mean, you're going to see, boom, standard deviation right here. And notice we have that symbol, little sigma. So notice we have kind of complicated formula here, but we're going to talk about what it means. And we actually talked about standard deviation back in chapter 1, so it should make sense. You take every x and you take away the mean. Why? Because you're looking for the distance from the mean. And standard deviation is usually, remember, the average deviation from the mean. So we take away every x deviation from the mean. Some are above the mean and some are below. So we square them to get rid of the negatives. And then we multiply that by its respective probability, because remember, there's a weighted probability aspect here. And then we add them all up, and there's your sigma, okay? So that is the formula. So we're going to write it down here on our notes first, and then we're going to talk about how to apply it and get full credit. Okay, so the formula is take your x, any x here, like x1, take away the mean that you just found, which is the expected value. That's your deviation from the mean. Square it to get rid of the negatives and multiply by your respective probability, okay? Then you're going to add all those up, and then you're going to square root, because you're not really just supposed to just square everything. You have to square root it, and that's going to be your sigma, okay? So now let's actually do, okay, here's the same example that we got from the previous page. So what I should have mentioned from the earlier example that I told you guys to do was that the mean was 8.128. This was the APGAR score of a baby, the expected value or APGAR score for many, many babies. If we took many, many, many babies, they would expect to get on average 8.128 on their APGAR score test. Okay, so that's the mean. I want to mention that. Why is that important? Because we need the mean in order to apply our standard deviation formula. So every time, guys, we're going to write our formula first in symbols from our reference table. So you're going to write x minus the mean, square it to get rid of the negatives, multiply it by respective probabilities, and then you add them all up. But remember, we have to square root it to get the standard deviation. If you don't square root it, it's actually going to be the variance. So I'm just going to do a few terms with you. I'm not going to do all of them right now. And then we're going to do it in the calculator. So let's do the first term. I'm circling it. The first x is 0. So I'm going to do x, which is 0, minus the mean, which is given above 8.128, square it to get rid of the negative, and then multiply it by its respective probability, 0.001. Okay, that's going to be my first term. Now I'm going to do plus. Why plus? Because sigma means add. Okay, so plus. Let's do our second term now. I'm going to do this one, 1. So the first x, next x is 1, minus the same mean, 8.128, square it, and multiply it by its probability, which was 0.006. Okay, plus. You getting the idea? The next x, 2, minus the same mean, 8.128, square it, times its respective probability, 0.007. Plus, all right, I'm getting sick of this now. So now I'm going to do a dot, 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 plus, and now I'm going to do my last term, which is going to be x equals 10. So I'm going to do 10 minus the mean, 8.128, square it, and multiply it by its respective probability, which is 0.053. Okay, whatever I get from all that at the end, that would be the variance. I have to square root that whole thing to get the standard deviation. Ooh. Now, do I really want to do that by hand? Absolutely not. But it turns out the calculator will give us the answer as well. So if we look back at my notes where it said in calculator here, we're going to do the same thing. Our data is already in the calculator in stat edit in L1 and L2. We're going to still look at our 1 var stat, but this time, instead of looking at x bar, which is our mean, we're going to look at the little sigma, and that's going to be our standard deviation. So I will show you that now using the old data that was in there from the question about Pete's Jeep tours. Okay, so here is the Pete's Jeep tour data still. And as you can see, if you look right down below the mean, which is 562.5, keep looking, keep looking. Do you see little sigma? There it is, 163.4587. So that is the standard deviation for Pete's Jeep tours, which means that on average, the cost that he will collect, the amount of money that he will collect per Jeep tour deviates from the mean by $163.46. So again, just a reminder, you put your data in stat edit. Once the L1 and L2 is filled with the X's and the respective P of X's, then you press stat, you go over to calc, you choose number 1 var stat, never 2, 1 var stat, L1 for your list, L2 for your frequency list, and then you hit calculate. Remember, if you only put L1 in, it will just find the mean of the standard deviation of L1 and it will ignore your L2. So there's the mean on the top, X bar, and sigma down below. Okay, so now what I want you guys to do is I want you to do this for this APGAR question. So I want you to put in L1, put in your X values here, and L2, put in your probabilities, and I want you to run the 1 var stat and find the standard deviation for this, and then we'll interpret it, and then we'll be done.